Hey, guess what's new? I'm back. Same day. Learning game development with Godot. Day 5, part 2. I wanna finish this. Get as far as possible in the last thing I've done, going through the lessons on the app. GD Quest, learning Godot. This is multi-streamed. I just need to get few things up and running here. I'll be with you in a few moments. I need to set up dashboards back again. They've resetted themselves by previous session close. Eddy's here, don't worry, no worries. Eddy's in the house. Oh. If you watch streams, then you're used to stream starting soon. This is how I do here, stream starting soon. I show you how I prepare my multi-streaming. Someone might say, why don't you do that before the stream? Well, not all stream platforms work the same way. They either close or break connection with the chat room, or activity dashboard needs refreshing for each stream session. It depends. When using the multi-streaming like Restream.io, not all chat rooms can be connected, and that doesn't allow me then to properly arrange all windows for all chats. I don't use third-party chat relay bridges, whatever, bots for this type of content when I'm doing work. Full screen. well, let me hit this stream arcade, go back here, and how to do properly this intro, well, official intro script, yeah. Hello and welcome, ladies and gentlemen. This is live recording session and a rehearsal. Live recording meaning as a creating a episode but recording it live on stream. Easier, that's way, that's easier way. It gets uploaded, I don't need to edit here, watch every moment, second, I little bit plan ahead, watch my language and then just cut it like in a meat shop and create smaller chunks, bites of this big thing. From Studio Lab at Edoga, a league for cancer league, which is me, Eddy Cancer. Working title, added as Internet of Capitalism. Restricted gaming, edutainment, working titles. But since this is the learning part, we're in a learning mode. It is the knowledge gift that keeps giving. If you're watching the long recorded version, you can jump at the end of the recording, not while live. There I do at the end a recap of the stream and then cut that, export it as a standalone video, and I put a link in the description where you can find either edited versions or VOD. All goes to my website, through my website. All links, maybe socials, other platforms. So it's the platform you're watching and my website. I'm not interested in other places. I don't work for Meta, I don't work for X, I don't work for YouTube. I'm not paid by Kik, I'm not paid by Twitch, I'm not paid by Odyssey, I'm not paid by Day5, I'm not paid by Trovo. Nobody pays me. All conversions done through my website. No growth through social platforms, just spreading thin. Forget about that. You want me? Come to my website. There's the intro. I have on my website free digital collectibles, Polygon NFTs, straight into your wallet, no gas fees. Pound. And they're not AI bloat, original, handmade. First series, first batch show. After a while you'll regret not getting yourself any. Now with the intro done, back to the overview, just for the sake of fun sake. Audio check. Yeah. I'll just sort out these, arrange them. Chats and dashboards for all these 5 platforms, so it's multi-stream to YouTube, Twitch, Kik, Trovo, Day5. Just 30 days streaming on Day5 and Trovo, and I think Day5 is progressively sinking on my list of target destinations. And also on workdays, Trovo almost has no viewership, living viewership. What are my best workhorses? Kik and YouTube. And I grew nicely on Bolt Plus, but they're offline, doing who knows where. This Odyssey breaks too often my live streams. Can't hold my large and long stream sessions, but I do publish that. That will be my main main outlet for video episodes. All other platforms will just have a short summaries for long periods, and I'll efficiently only use the embedded videos on my website in like fancy versions from Odyssey uploaded there. I don't create content for, like I said, Google, Instagram and those, they don't pay me. All conversions on site, content on site. Site's legit. Turn off your ad blockers so we can make money over here. Twitch dashboard. YouTube, I've got some traction recently on YouTube with the Godot and Blender content. 2 streams, 3 streams, 4 streams. But I'm actually again thinking, should I perhaps, let's say, spread to Far East, like Far East Korean streaming platforms. China platforms are too close, they require, I don't know, too much verification and being involved in their official state social network and identity checking procedures. While Koreans are maybe a bit more relaxed on that matter, and I might just do a stream dedicated gaming content. While this content where I talk a lot, I might just keep on the Western hemisphere, Northwestern, Western. Oh, South also, well, I mean global English, world English spoken audience for us here. Well, at this time I've squeezed these quite a lot, I have extra space, what's going on? I had also a lot of traction on Twitch when I was playing Breath of the Wild, Legend of Zelda. That brought some views last year. And this season it's the Blender Godot content, so let's go. Is that all sorted, ordered? Yeah, cool. Right where I stopped previously a few hours ago. Here we are. Conditions, GD script, learning. Conditions we've done. So far we've covered variables, functions, member variables, I mean subvariables, declaring, defining functions, function calls, passing value, local scope related to variables scope, whether they're usable inside, outside, code blocks, functions declared outside, inside. And I like this is very basic tutorial, but this type of syntax and code formatting, code writing with the tab in the indentations for code blocks and code logic-like functions without curly braces. With these, I want to get used to it. This is maybe the, for me, best and most efficient way. And in previous lesson we decreased and increased characters' health, but there were no limits to how much health they could have. So now we need to introduce conditions to cap low and high health status for character. Function take damage amount, health minus equal amount. Okay, that's the example for previous. As a result, the player could increase character health. Yeah, infinite, yeah, going. So we need conditions. What happens to health when we damage our character? Suppose our character has 100 health. What would the value of health be if we call take damage 25 times? Take damage 5 times. Set 1, 2, 3, 4, 5, minus 25. We can use conditions to run actions selectively. Conditions make your code branch in 2 parts, but not restricted to. Otherwise, those instructions will not run at all. So conditions code branch in 2 parts: executions and the code logic written. If the condition is met, the computer will run the corresponding instructions. Otherwise, those instructions will not run at all. Video games and other computer programs are full of conditions. For example, game input largely relies on conditions. If the player presses the button on a gamepad, the character jumps. Jump, 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 a jump. When the computer checks a condition, this is called to evaluate a condition. All conditions evaluate to their true, either to true or false. Either the player is pressing the button or not. Either the character is touching an enemy or not. In our case, if the health goes over a maximum value, we want to reset it to the maximum. Cap it. To define a condition, we use the if keyword. We write the line starting with if, type the condition to evaluate, and then end the line with a colon. So this thing here, if health, what's this, greater than 100, colon, which opens actually the block of instructions that will get executed for this condition being met. And that's how that goes. So no curly braces for code blocks, code segments, code logic, objects, functions, classes. Notice the comparison sign greater than, where this symbol is greater than. We've seen how function definitions use a colon at the end of the first line and nest content inside. In GDScript, this syntax is recurring pattern for all code blocks. The computer knows which instructions belong to the condition because they are indented. Got that? I'm just here checking. Can I? There is no pin a message or a message in chat on Day5 so far I've seen. And to continue with this. Okay, so on this example, function heal amount, health plus equal the amount, if health 100 greater than, cap it at 100. So if I press heal, that's running, that's a call to function with passing 50 integer value. Guys, 100 health. If I press more, it's just 100, no more. But if I step 75, 125 greater than, and well, debugger doesn't show here, there is evaluation boolean result, but it shows the variable that it's kept like hard-coded, assigned 100 as set maximum for this game design, for this game logic. Comparisons. In the above example, we use the greater than syntax to meaning greater than. We compare numbers in other ways too. Well, what's this? Angle bracket means angle, or what angle? How to read this angle bracket? Right means greater than. Left angle bracket means less than. In in evaluation and comparison, double equal sign is used for in the evaluation of expression. So this is like asking, is this equal to? Not equal means different or not equal. Different programming languages treat the values strictly. Coming into the expression needs to match requires matching variable types, and some not strict typed languages tolerate everything, and you can have problems even when apparently there is the same value number, but maybe you got the number from some, I don't know, external API JSON format, and it's not strictly typed. Typed numbers can sometimes turn out to not be equal to. Maybe it turns out you got the text with number characters evaluating against the number type, integer, float, double, or whatever. So type checking for your use case. Example for different types of these. So here is the if statement comparison, evaluating expression health greater than 100, health less than 50, health equal 25, health not equal 7. What does past do in the code? Wow, it means expression is evaluated as true. The pass keyword prevents error in our code when a line cannot be empty. For example, we must have a line of code. Okay, so here this is a keyword pass. So it means we're just evaluating this for the purpose of example, and I keep the code error free. Since this is opening a code block, it cannot be empty, but pass will prevent error. For example, we must have a line of code after function definition or an if block. When you don't know what to write yet, you can use pass keyword as a placeholder and Godot won't give any errors. In the previous example, if there was nothing below the if lines, Godot would give us expected an indented block after if error. Karen, the bagger code checker, Karen level. Okay, let's go to this gate. 1 not equal 3, no. 3 less than 1, no. 2 equal 1, no. 2 less than 3, yeah. 3 greater than 1, yeah. God level. Impressive. Or else, if the if keyword comes with a complementary else keyword, the fabulous ass-kissing else, trying to suit everybody, to please everyone else. I'm lazy to find out another expression. I'll just use else. You can write an else block after an if block like so. So if there are same level alignment, column alignment, like if, but every if can have its else that's probably in a precedence order evaluated as a by the code checker. I hope they won't waste our time with giving a lot of examples about how can this be misused with wrongly in a bad syntax. Okay, that's cool. You can write an else block after an if block like so. Run. You're fast. So speed equal 120. If speed less than 100, you're slow. We have to be fast. Running always the same since value is hard-coded. Stepping, function run, first step, second step, speed 120, assignment, evaluating this, else, oh, you're fast, you be fast. The else block will return whatever the condition above isn't, whenever the condition above isn't met. In the following practices, we'll use conditions and improve the way our character's health changes so it has limits. Practice! What up? Using comparisons. Comparing values allows us to make decisions in code, but there's something wrong with these statements. Practice, practice, practice. Exercise. This series of if statements is all wrong. Change the comparison so each comparison matches the instructions below it. Keep the values and statements as they are, only change the comparison sign. The line health less than 5 means health is less than 5 because health equal 100. This is false, so print health is greater than 5 won't run. Okay. Gotcha. Health equal 100. Greater than. Then greater. If 1 greater than health, 1 is less than health. Okay, I think this is right? Health less than health. Health is equal, no. This should be then equal. Health less than 7. And this should be not equal. Where? Health is 100. Health greater than 5. Yeah, that's good. 1 greater than health. Oh, sorry. This is okay. Tell me, yeah, cool. Let's go. Keep it rolling. Limiting healing. We have a heal function that adds an amount to the character's health. Add to the function. So the character's health is never greater than 80. Health doesn't go above 80. Okay, so if health what would that be? Greater, yeah? Greater than 80. Health equal 80. That doesn't go above 80. Health limit is not too low. Okay. Health takes different values. What? I'm trying to little bit speed this up, but not too much. You can use a condition to check if the health is above. Okay, I can do that. You need to reset. Okay. Yeah, I got that. So health doesn't go above. Health limit is not too low. Health limit is not too low. Health takes different values. Maybe I'm overthinking this, but okay. Prevent health from going below 0. That's cool. When the robot takes damage, its health can be negative. You might want to display the health number on screen like in Japanese JRPG. We don't want negative numbers, we want to stop at 0 instead. Calling the function should reduce health by the amount. If health goes below 0, set it to 0 again. So health function is damage taken, amount. So if health less than 0 or 1. Well, that should also be taken in considerations, 0 or 1. Especially when somebody is evaluating array indexes. Health, yeah, so health equal 0. This should be enough. Again me, again stealing, being cheap on that H's, on those H's. Look at that, multiplying. Or robots' health is always between 0 and 100. Level up. But as our robot fights, we want to increase in strength or toughness. When a character levels up, it might deal more damage to enemies, gain new abilities, or, in our case, gain more health. We define level variable to keep track of the level of the robot. It starts at level 1. When the robot has defeated enough enemies, we call the level up function to increment the robot's level. Hey guys, level up. Variable level equal 1, function level up, level plus 1. Okay, as we briefly say in the last lesson, our robot could have a range of variables that could increase when it levels up. So health 100, max health 100, power 5, defense equal 2. In this lesson we'll just focus on increasing robot's max health. The variable max health is maximum amount the robot's health can be. We can change our heal function to use this variable. Yes, so we evaluate instead of the fixed hard-coded value to the variable max health that will be modified on another place, like in level up function. We could add 5 to max health every time the robot levels up. Okay, function level up, next level plus equal 1, max health plus equal 5. This would increase max health the same amount every time. If we graph max health, it looks something like this. Show me. Boing. Linear progression. In our case, we want a feeling of more and more power as the robot levels up. We want a graph like this. Show me. Boing. Oh, parabolic, exponential. With each level, more max health is added than the previous. More max health is added than the previous level up. To get the exponential growth, we multiply the max health by an amount greater than 1 each time the robot levels up. To multiply values together, we use asterisk or multiplication character used. What is the value of damage? Function calculate damage. 5 times 3, 15. Yay. We can use multiply equal in the same way as minus equal and plus equal, or add and subtract, add, multiply by with itself. What's the value of damage now? 3.5 power level 15, 30. Let's level up our robot and exponential growth to max health. Level 1, max health 100, level up, max level multiply by itself bit 1.1. In the practice, you'll increase the robot's max health and add a special ability to a robot to make it extra tough at high levels. Practice. Let's go. Okay, so here is the full screen. Let's do it like this. But okay, this will be for the whole learning course up. Increasing maximum health exponentially. Let's make the robot stronger when it levels up. Add to the level up function so it does the following. I'll try even do better. Where is my magnifier? Yeah, here it is. Step. Speed of what? No, I'm not interested in change zooms. Click the zoom increments. Okay, 25 or maybe even 10. Let's try 10. So if I say zoom, yeah, we get something better. If I zoom more, the thing is that the zoom works on the center, something like this. Let's make the robot stronger when it levels up. Adding to the level up function so it does the following: increase level by 1, increase max health by 10%. Okay, so level plus equal 1 and max health times 1.1, right? Yep. Who is the man? Who is the man? Who is the man? Reducing damage at higher levels. Oh, when our robot's level is 3 or more, we want it to take a lot less damage. Add to the take damage function so the following happens. If the robot's level is greater than 2, reduce the damage amount by 50%. The robot is level 3 and enemy is going to attack for 10 damage. This damage should reduce to 5. Damage amount is correct value. Multiplication is used to reduce damage amount. Checks. Hints. Level 3, health 100, max health 100. Hints. You need to use an if statement at the top of the function to check if there is greater than 2. Okay. To reduce the amount, multiply it by a value less than 1. Multiplying by any value by 0.5 reduces by 50%. Okay. Health minus amount. Okay, so here health gets assigned, and that will be if level greater than 2, then it should be 3, right? Oh yeah. So amount times equal multiply by 0.5 and that should be it. That should do it. What does it say? Damage amount is correct. Multiplication is used to reduce damage. Okay, so continue. To D vectors. People to D vectors. This important. That's important. This allows us calculate directions from coordinates. Yeah, you know vector algebra, 2D vector algebra, basic stuff. Add, subtract vectors. Analytics basics, analytics geometry. Anybody? Suppose we want to increase the size of the robot when it levels up. Size of robot, increase the size. As you may recall, we do this by using the following code: scale. No, we didn't use that. You're wrong. I've done it all today. Whoa. Big boy. As we talked about in lesson 7, the scale variable has two sub-variables to it, x and y. This is because scale is a vector 2, which stands for two-dimensional vector. A vector represents two coordinates, which is actually 4 parameters. There is a point for vector start and end point of a vector, and each point has xy and xy coordinates. What are vectors? Vector in physics is a quantity with a magnitude and direction. For example, a force applied to some object, velocity, speed and direction of a character, and so on. We often represent this quantity with an arrow. In Godot, 2D vectors are a common value type named vector 2. Unlike plain numbers, they store two decimal numbers, one for the x coordinate and one for y coordinate. Well, then to reduce to, if we need to calculate the vector position in the against some other vector, we can take in consideration, for the single vector we can reduce its starting point to zero it out to like the starting point of coordinate measuring system, like 0, 0. We can take for granted that it is start point for vector. But y represents 2D coordinates. A vector 2 represents a vector in physics with an arrow. Vectors are common value type named vector 2. Unlike plain numbers, they store two decimal numbers, one for x coordinate and one for y coordinate. So far you've come across two variables in the course, which are vectors. Which are they? Position, scale, scale. No, not speed. Why? Scale, speed, submit. Okay, there. I was thinking outside my generalizing it. Both scale and position have x and y sub-variables, so Godot uses a vector 2 to store their values. Vectors are great for games. Vectors are essential in video games. They allow you to represent your mom and pa. Think my music's too loud, right? Nobody is saying anything. Why? Say it. Say it. Sound check. I'm just doing a sound check. Now it's much better. All those hi-hats in my soundtrack are too annoying. But better have something than nothing. But I should keep it at a lower volume, especially for use on headphones. After I don't know, hour and a half, it really probably gets annoying. I need to export more music tracks originals from my Fruit Loop projects for more variety in the show. What's up? 52 minutes in. Okay, good. Keep the pace. What's this guy doing? Hey, leave my mouse on. Hey, go. Ooh. They allow you to represent a character's movement, speed and direction, calculate the distance to a target and more with little code. But there is a code. It's not that that code doesn't exist. But there is a basic universal framework behind in the implementation of Vector 2D that does the arithmetics calculations and evaluations for vectors. Take this turtle AI below. You've probably seen games where enemies move like this. This is done with just 7 lines of pure vector calculation code. The code is a bit too difficult for now, so we'll spare you the details, but this turtle gives you a glimpse of what 2D vectors can do for you and your game projects. Do vectors get dizzy? Can vectors get dizzy? We scale the robot again, this time by adding to it directly using vector 2. The following code has the same effect as the previous example. Level up, scale plus equal vector 2, 0.2, 0.2. Level up, 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 level up. Notice how we use parentheses and 2 arguments inside parentheses, just like other function calls. We call this a constructor function call. Constructor function call? You can think of it as a special kind of function that creates a particular type of value. The code vector 2, open parenthesis 0.2, comma 0.2, close parenthesis, constructs a new vector 2 value with its x set to 0.2 and its y set to 0.2 respectively, using vectors to change the position. We can add and subtract vectors to position because it's a vector. If we wanted to move our robot to a new relative position, we would add a vector 2 to its position. Okay, I can deal with it. Move, 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 move. How would you move the robot? 50 pixels to the left. You're right. Position minus equal vector 50, comma O subtracts 50 to the subvariable x and 0 to y. Position dot x minus equal vector to 50, comma 0 tries to subtract a 2D vector to the subvariable x, which is a decimal number, and there are different types, not the same type. The value types are incompatible. If you try to do this, you'll get an error. In the next few practices, you'll use vectors to change scale and position values. Is that clear? Practice increasing scale using vectors. Okay, to visually show our robot has gained its strength, let's increase its size. Every time it levels up, nothing could go wrong. Okay. Increasing scale using vectors. Add a line of code to level up function to increase the scale of the robot by vector 2, 0.2, 0.2 every time it levels up. So, level up instructions. Increase the level variable by 1, increase the health, and then scale it. Scale plus equal vector 2 0.2, 0.2, 0.2, la. Correct scale after two levels. Add a line of code to the level up function to increase the correct scale after two levels. Well, wait, go. Add a line of code to the level up function to increase the scale every time it levels up. Use a vector to increase scale. Resetting size and position using vectors. The robot's level has increased a lot and so has its size. Let's fix this. By resetting the robot's scale and position values, create a function named resetRobot that sets the scale and position of the robot. Create a function named resetRobot that sets, function reset Roboto. The X and Y subvariables of the robot scale need to be 1. Well, okay, then just scale I would say okay, scale X is this how this works? Scale X equal 1. Does this matter? Are we talking about this? Oh. I don't need vectors for this. And I already forgot how to use it, but I can check my hints. Hint 1. To define the function, use the okay, yeah. The first line, reset robot. No way. So, well, position, I'll just say it's equal to vector 2 0 0. Because I'm guessing that that will zero it. It needs to get zeroed, yeah. It's not the scale thing. This must work. This definitely has to work. Oh, you want that for that. Well, I guess then that would be vector 2 1 1. Do I need the decimal? Can I test it? Come on. My vector is good as your vector. I'm not yelling. Introduction to while loops. You've seen that you can use functions to reuse code. In this lesson, you'll learn about loops, and that's cue for the short break. Hour in the stream, or maybe like previously, add 15 minutes in an hour to compensate for the show boot up period, first 10 minutes. Okay, continue to illustrate how loops work. I know how loops work, but let's say I don't. Let's take a game board split into a grid. Our robot can move to neighboring cells by changing a vector 2 variable named cell. Our robot can move to neighboring cells by changing a vector 2 variable named cell. Okay. It represents the current cell the robot is in. Okay. When we increase cell X, the robot moves to the right. Okay, I get it. Note that we delay the robot's movement in the app to help you visualize how it moves. The following code would normally move the robot instantly. What? So, next cell, select. I understand. Diagonally. Why? Move to end, so I am expecting it to come here. The above code works for a predefined board with a size of vector 3,3, but the move to end function wouldn't work if the size of the board was different. Move to end. Well, that's because it's fixed, hard-coded. The robot wouldn't either stop before the end or go too far. To implement a general solution for all board sizes, we can repeat the robot's movement until it gets to the end. For code that repeats, we can use loops. Using while loops to repeat the code. You can use a while loop to make the computer repeat a block of code until you meet a specific condition or decide to break from the loop. I want to break while loop. Here's how we use a while loop. Variable number equals 0, while number less than 4, print number plus increase number by 1. We use the variable number to keep track of how many loops the while loop completes. Each time we go through the while loop, we add 1 to number. The while loop keeps running for as long as the condition is true. In this case, it keeps running while number is less than 4. You can see that the following code is executed 4 times in the console. Run. So printing to the output, print number 0, 1, 2, 3, 4. Oh, yeah, that's the thing. Number starting from 0, but less than 4. Step. Number 4. And that's the end. Wait, let's check, let's have another look. So, number equals 0, number 0, debugger. Evaluation, yeah, less than 4. Printing, we get the output of number 0, first one. And then the increase happens. We increase by 1 the number. Stepping, we are not going outside anywhere, just looping from 3 to 5 until condition is met. Evaluated as true. Step, yeah. So last state of number, value stored is 1, less than 4. Step, printing it, so it's 1, and now increasing it. Okay, number 2, evaluated, it's less than, printing it, so it's 2. We got 2 stored, but we got the increase. So we got print of 3 output prints, but number is 3, and we see 0, 1, 2, 3. Okay, this could be also done with equal, if it would be assigned here, initialized with 1 and evaluated to equal to 4. But this is making sure that from some external source this number is changed to a greater than 4. This evaluation makes sure we are working within the less than 4 range of values for number. That's why it's not this evaluation in a while loop statement. Comparison is not checking for equal equation. Yeah, is it equal to, but less than, because the while number might appear from some reason, let's say bug, higher than 4, and the statement would evaluate no, it's not equal to, and still keep looping. Let's apply this to our move to end function. This time we complete the number of loops to the board's width. We go through the loop until we reach the width of the board. Note that we move the robot until its position is 1 less than the board's width, because we are counting tiles from 0, yeah. Board of 3 by 3 cells would have cell coordinates going from 0 to 2 on both the y and x axis. Function move to end while, okay, so while cell x less than board size x minus 1. Cell dot x increase by 1. So cell is the okay, cell is a member variable of the roboto. I can change here in this demonstration width, move to end. Oh, he's just sliding to the right. 3 previously moved to end was just okay. It's well, the command is instructions are just increasing the x part. While loops can cause issues, yeah. If you are not careful, your while loop can run infinitely. In that case, the application will freeze. Take a look at this code example. Variable number equals 0. While the number is less than 0. Draw square. That's it. Okay, so the number is initialized and never changed, and that will be forever. This number will never change, and condition will never be disproven. What will happen if the computer tries to run this code above? It will draw squares infinitely until program is terminated. Submit. Because we don't increment number, blah blah, cool. When to use while loop? At first you will not need while loops often. Even the code we show here has more efficiency. More efficient alternatives. Also, there is a safer kind of loop for loops which we'll look at in the next session. Yet, While loops have important intermediate to advanced level uses, so you at last need to know that they exist and how to use them. Got that? Clear? We use while loops every time we need to loop an unknown number of times. For example, games run in a loop that typically generates 60 images per second until the user closes the game. This is possible thanks to while loops. There are other good uses for while loops: reading and processing a file like a text document line by line. Processing a constant stream of data, like someone recording audio with a microphone. Reading code and converting it to instructions the computer understands. Various maps for AI. Let's practice some while loops as they're useful to know. It's also an excellent opportunity to practice to the vectors. Then we'll move to the safer for loops in the following lesson. Practices moving to the end of a board. Use a while loop to have a robot move to the bottom. Come on. Moving to the end of a board. Our robot has decided to stand at the top of the board. Complete the move to bottom function so the robot moves to the bottom of the board. The board size is determined by the vector to board size. The robot's current cell is vector 2, 0. Make sure to use a while loop so the function works any board size. Let's do it. Checks. Robot gets to bottom of board. Use while loop. Hint. You'll have to alter the Y subvariable of cell to move the robot downwards. Okay, we move. We just go bottom. Bottom. Cool. Move to bottom. Move to bottom. While any board size. So what do I want to do? So I might just, let's say I don't need to count the steps because I don't know them, but I should know going to bottom. I should know the Y, right? While cell current cell is vector 2.0, so it's on top. Is that the fact? To move the robot down, cell 1 needs to increase. I'm not, it's not strict to using vector. Okay, use while. Yeah, that's what, yeah, exactly. So I don't need to do a counter, invent the counter. So cell dot y. Okay, so board size dot y minus 1 because we're going You're going one less. Going one less. We don't need to go that next step. Wait, why not? Why wouldn't? Board size. Does well if he moves. Okay, he moves that many places, but as a evaluation, I need to trim the number because of the zero index. So to move, I should say, okay, I should say cell, cell y plus equal 1. Can I see that? Reset? No. Okay, good practice, good exercise. So, okay, I get it. While cell dot y, come on, less than board size. This is good for exercise for brain memory cells. -1 for the take into account the index. Just cell that y plus equal 1, and I need to watch the animation. Wait, you just jumped. Why did it just jump? Oh, maybe I do the how about I do the, what if I call, maybe perhaps use the process delta, or just maybe try get the delta. Try this, try delta. Is delta available in any shape or form? No. I thought it was a global thing. And now the short break needs to happen. I'm not going anywhere. Maybe I am, maybe not. Maybe I'll go. I know. Maybe. I don't know. That came pretty quickly in. Is this true? 3 viewers on Day5. Day5 needs to fix the left and right column for dashboard. Otherwise, dashboard is good, but I can't pop out over there the chat from there, and it at least shows how many viewers at the moment or passing by. We'll see. Okay, let's go, let's go. Chill this down. Changing to this. Introduction to 4 loops. But not 4 of them, it's 4. 4. For what? Additional. What does this mean? It means it's possible to set the number how many loops to execute. In the last session we worked with while loops. We found they were useful if we don't know how many times we should repeat code. Just before I continue, one quick sound check on the stream. Yeah, nice. Who is that guy? He speaks so wonderfully. Okay. So, sip of coffee. However, those while loops can result in infinite loops if we are not careful. The loop below never ends. Okay, never ends. Loop you never end, go away. There's a safer and often easier kind of loop, the for loop. We'll look at it in this session. Unlike while loops, for loops don't run infinitely. It's much less likely than that you'll get bugs in your game. We recommend favoring for loops over while loop because of this. Let's change code above to use for loop instead. The loop below will change the cell 3 times for number in range 3. Okay, cell plus equal vector 1 1. Let's explain what's going on here. The range function. Godot has a helper function range, calling range n creates a list of numbers from index 0 to n minus 1. What? So it means if I say range 2, it will start at 0 to 1, right? So calling range 3 outputs the list of numbers 0, 1 2. And range 5, 0, 1, 2, 3, 4. What list of numbers would range 6 create? Okay, 1, 2, 3, 4, 5. Well, you just said it, so you're right. Of course I'm right. How for loops work? In a for loop, the complete tasks, each value inside from the beginning. In a for loop, the computer takes each value inside a list, stores it in a temporary variable, and executes the code in the loop once per value. Okay, pretty simple. Run 0, 1, 2, 3, 0, 1, 2. Step. No, not going through that. In the above example, for each item in the list 0, 1, 2, Godot sets the number to the item, then executes the code in the for loop. Wait, what was the code anyway? Okay, for number will be like a control variable. Okay, so this is it's a you can name this whatever you want, but it's just, if you change it within a code, you can break this thing also. We'll explain arrays more thoroughly in the next lesson, but notice that number is just a temporary variable. You can create it when defining the loop, and the loop takes care of changing its values. So also you can name this variable anything you want, just like I said. Oh, for element in 0, 1, 2, print element. In both examples, we print the value of the temporary variable we created, number in the first example and element in the second. As Godot moves through the loop, it assigns each value of the array to the variable. So range is an array. Can it be multi-dimensional array? As Godot moves through the loop, it assigns each value of the array to that variable. First sets variables, then 1 and 2. Okay. We can break down the instructions the loop runs. You can see how a loop is a shortcut to code that otherwise gets very long. Okay, this is like a plain code example of doing something 3 times without the loop, but without using the for loop. We can put whatever code we like in the loop's code block, including other function calls like draw rectangle, using a loop using a for loop instead of while loop. Here's our old move to end function which used while loop. Cell board size cell. Okay, if we use for loop instead, the code becomes a little simpler. Function move to end. For number in range, board size x minus 1. Well, it's simpler or appearing more complex, but it's not simpler, it's safer. Well, but here's their here is what they have to say in their defense. Rather than constantly checking if the robot reached the end of the board with the for loop, we take the board's width beforehand and move the robot a set amount of times. The function still works the same, you can execute it below. In range board size, okay, in range board size, okay, I got it. Wait, so if board size is 3 and we start the 4, so okay, the range will get each time. So first first execution of 4 will get us board size of, will get the array 0, 1, 2, and that, I guess this expression is executed only once for the first for loop run and never changes. And then, since it is for first loop, the number value is 0, and in first step of a loop, first loop, cell by 1, moves it next for the 3 cells with wide board, 1 step, but we need just 2 steps. So first cell is occupied, 3. Oh, I get 2, so I get only 0 and 1. Okay, that sorts it all out. In the practices, we'll use for loops in different ways to get you used to using them. Using a for loop to move to the end of the board. Use a for loop to have our robot move from the top of the board to the bottom. Once again, the robot has decided to stand at the top of the board. This time, use a for loop in the move the board to bottom function to have it move to the bottom of the board. The board size is determined by vector 2. Variable boards is board size. The robot starting cell is vector 2.0. Well, for the step, I'll call it like this at this moment. Range of board size y minus 1 so I got to call then this, I guess, cell dot y plus equal step. Sorry, where 4th step, so where what? Board size, yep. Line 2, column 1. In 4th step. Okay, oh, sorry. In range. I'm new here. It went over. Why? Yes, I did. So why did this happen? Why did this happen? Let me check the hints. Hint 1. You have to, okay, y subvariable of cell. Call range n to get a list of numbers from 0 to n-1. Yeah. Use for number in range board size -1 to loop enough times. And why one? How did I get one too many? Why did this cause one too many steps? Is this 2 steps too many? So if the board size is whichever it is, and I'm at the first spot and I just need to move 1 less than the board size. Set, with what? Step. Okay, so for step in range of board size -1. 1, 2, 3, 4, 5. I get 0 to 4. But how would I know? I need 4 steps. 1, 2, 3, 4. 4 steps. What would be my thought process making this sure? Well, okay, well, reset. Okay, reset. So he's here. It could even be that there was a bug here. Let's do this again. 4 step in range of board size. Y last bottom board size y -1. I move cell.y increase by step so something's weird here. I'm saying step would be 0. Yeah, step would be 0, right? But I get one. Wait, this guy is. What's he doing he's not on top, he's in a second. Starting cell is vector 2.0. He's not in 2.0. is already way down below. What? Reset. Move to bottom. What's going on here? Is there a bug? Bug here? Or step in range of both sides. Dot y, right? -1. But it's -2. Just cell dot y plus equal step. Why are you so weird? Why is he moving? Who's moving his is there a bug here for range bow? No? Vector 101. Why did he move diagonally if I was just changing one? Why did this guy move? Let me evaluate this. Let me get the solution and use it. Use solution. Run. What's moving this diagonally? Why is he moving to the right also? Using a for loop to move to the end of the board. Once again, the robot has decided to stand at the top. This time use a for loop in to move to the bottom. The board size is determined. The robot starting cell is 2.0. Well, why don't... Okay, I know what was wrong with my code. I was increasing the number of steps the cells moved. Each loop I made my robot move for a greater step. I increased the step value, not just by one. That was my error. So if I reset and I do it my way, so for step in range of course board size -1, but of a y I say cell dot y plus +1. I don't care. +1. Ah, there's a bug. I feel that there's a bug here. So maybe I do this then. Cell cell equal vector 2 0 0. Let's reset this guy. Huh? Okay, I got it. So this function doesn't have outside. I can say this run and if I copy all this and reset and copy all this and paste, do next run. Now I'm making sure that, well, at first this is what they say. This is what they say, and this is how the description is telling us. Vector 2, this is starting cell of the robot. And that's for some reason he's drawn in the wrong column, let's say, on the wrong x coordinate. And there's no need for a vector 0.1 because not moving him both ways. Okay, bug. Some sort of bug. Maybe if I go back and step back out in the lesson chapters, maybe it can sort itself out. Improving the code with a for loop. The goal is use a for loop to remove the duplicates in code. Run function, run, jump, draw, jump, draw, jump. Okay. So here's what I'll do. For move in range. So do I use what range? 0 1 2, right? I jump once and do this, so it's all the same. Is this the thing? So x, first place is x. I'm in the same spot. Void jump range int. Hint. Well, okay, range 3. Oh, I got you. 3. do I need to jump? Do I need to, is there imperative to jump first? Do I jump last? Well, I might just do this then. Jump to 100. Zero. Plus move it times 100. Move it times 200. Not 100 pixels apart. Well, these things are important to figure out properly. Get a proper what you call it, get a proper assumption. Assume properly the movement, predict. Yeah, I need to predict this for my project. I cannot. This guy doesn't give me. Well, it helps. It's helping me. He's helping me. Yeah. He's good. Okay, moves in range. Draw rectangle. Wait. Can I run this again? He draws a rectangle, draws it again. Okay, I get two. So what are these jump functions? Jump and draw. What? Okay, I get here meta description. Jump is a float. Float offsets the turtle position by a given length and height. So it height and length. So at the position, so I need to offset the turtle's position. So I need to jump. But I can also draw it at the same place. Since my first move is 0, the turtle didn't jump, it jumped in the same place. And what I need to say is perhaps this, which is maybe a bit more complicated. Can I do this? Plus, but if it's 0, it will not help me. This won't help, but then like this, move. Do I do this? I do this. I'll do this like this. Okay, so move plus 1. And this guy is also +1. And he'll do it 3 times and that's it. But it's not 500. Oh no! And then even again. Again. Do I need to I don't need to multiply this. Wait. 3 rectangles. And each time I jump, so I don't need to do anything here. We don't need to increase because all these are added to the current location. I thought I thought the jump are the specific coordinates, not relative. Creating arrays. The range function we saw in the previous lesson outputs a list of numbers. For example, calling range 3 produces the list of numbers 0, 1, 2. A list of values, numbers or otherwise, has a precise naming code. We call it an array. So we can say calling the range function produces an array of numbers or enumerates. We get an enumerated sequence. Since it's one field structure, one-dimensional field structure, it's not a pair, two-dimensional. A list of value numbers or otherwise has a precise name code. Function produces array. Okay, we could directly write and use that array inside our for loop instead of the range function. You can run the next function step by step to see how it works. Okay, so it needs angle brackets, right angle brackets. Hey people, how are you doing? Why is this throw thing not scrolling? How it works? Well, I understand. I get it. Run. Step. Number 0. Number 0. Here. Okay, cool. As you can see, the code still works the same. Notice that we create a for loop. We also create a local variable to which the loop assigns one value per iteration. Above we named it number because the array we loop over contains 3 numbers. But we could name it anything we'd like for element. Yeah. If we unwrap the for loop above, we'd get the following code with the exact same behavior. Yeah, same thing. So this is array equal. So we create our own variable called array. We assign it a array and then call first, second and third field element of that array. But this example actually doesn't tell that we might have different values in an array, but we would call them to get to get this value in this position in this array, we would call 0, but here can be any other value, and still to get a value from this position we would need to use first element in array is always 0, but the element could be who knows what. So these are the elements and these are the indexes, the syntax of arrays. We write this way in GDScript. Value 1, value 2. You start with an open square bracket, okay, square bracket. Then you write comma separated values that compose the array. Finally, you need a closing square bracket to complete the array. Here's a couple of valid arrays. Notice how you can mix values and how they don't need to follow one another. Like I was saying, so 1, 2, 6, 7, vector 2, okay, vector storing different types. Because arrays themselves are a value type, just like numbers or vectors too, we can assign arrays to variables. Okay, they are value type. That's why they can be assigned. To re-access them later. That'll come in handy in the next lesson, where we'll use those variables in loops. Okay, example, assigning numbers a value of an array and creating vector and numbers variable and assigning it an array of mixed types, vector, integer, float. Or is it this? That's decimal. I think this is float. Signed float. Or double, not sure. But first let's see when you'd use an array. When you use arrays. In computer programming we use arrays all the time. Precisely, you'll use them whenever you need to store a list of things. You always need lists of things in games. The player's party in the RPG, the items in the player's inventory, the high scores in an arcade game, the objects in the game world. All of those and many more rely on arrays. Using arrays to follow a path. What? Let's look at the widespread use of arrays in games. Finding and following a path. In games you'd need allies or monsters to find their way to their target, whether it's the player or some point of interest. To achieve that, we use path-finding algorithms. As the name suggests, those algorithms find the path between 2 points and allow AIs to traverse the game. Many of those algorithms use arrays of vector2 coordinates to represent the path. Okay. Take this turtle pet. It wants to follow the robot, but there are rocks in the way. How can we tell it where to walk to reach the robot? With an array. Hooray! Path to robot. So vector 1, 1-0, 2-0, 2-1, 3-1, 4-1, and from which side to approach it. 1, 2, 2, 1, 2, 2, okay, going. So I guess getting the same on the same row would be the best approach. Vector 2, 3 and vector 4, 2 like here. Did you all see that? There's the AI. Every value in the array is a vector and represents a cell the turtle needs to walk through. Yeah. Together all the values in the array represent a path we can draw. Why would I draw it? It's not like the turtle is looking at it. In upcoming lessons, we'll see how we can use arrays to store players' inventories or design attack combos. For now, let's practice creating arrays. Short break now, and then go into practice. Well, what's good about all this is that it seems a lot, but like in everything, when learning, working, building something, first it's hard, and then I don't know, am I halfway through? But it's good chunk, and it's altogether 5 hours. These two sessions, very efficient. The current session and previous 3-hour session, learning the programming language, the culture, discipline of typing, and the abstracts. And it didn't take me weeks, years. It took so far 5 hours. I do have some background, so it's easier for me. I'm just reintroducing what I learned before into this programming language. So I had to take this hand guiding exercise to do exactly that, reintroduce my previous learned skill to this format of programming, of code. Well, that is just because I'm saying that because I really have 2 almost grown kids. One is legal age, one just at the step, at the threshold of maturity, the legal age at least. And they can't go over these things. They're completely different than me. I have patience, but most importantly, a desire to learn, especially creative, descriptive languages. And they don't have patience for that. I suggested and gave my son like a task, like a hobby task. Take this book, follow the lessons, and you'll know to program. You cannot unlearn that, even if you don't want to. Most things in life will be things that we don't want, so why don't do something that's really practical, interactive? And he did do some steps, and it turned out, actually, he took it like I was abusing him. And I said, you don't need to do it, but you test yourself, what you're made of. What path are you setting yourself onto? If you refuse to do this, yourself a big favor. Imagine what will be your decision when you get in the real life situation. What will you decide? How will you react on every other thing that you don't like in life, which are majority? So it's best to find a approach and learn how to like. Do yourself a favor and learn how to like things you don't kind of like. They're not hip pop or whatever. Those boring bits. Just wanted to give them a suggestion and guide them away from the, I don't know, taking life lightly and ending life like a employee in whichever business entity, corporation, job, whatever, doing something very linear and being stuck in that. And like I said, it turned out that me suggesting my kids I will be stubborn and I will suggest numerous times, do it, but you force yourself. Learn to take yourself seriously about things you want to, you should do. Make it easier for yourself. Learn how to want to do them. Don't leave like a mandatory tasks, chores, whatever, obligations hang like a things you're intuitively opposing to causing friction for no reason. Remove that. Change your attitude, so reduce that friction. No, it turned out that I am the abusive father. Let's go into this. Two practices for the race. Put back on the soundtrack of the show. And sip of coffee, and let's see. Walking to the robot. Help the turtle find its way to the robot. Give it a path to follow to reach the robot. Selecting units. Okay. Turtle wants to meet the robot, but it cannot find its own way. Fill the turtle path array with vector 2 coordinates indicating where the turtle should move to avoid the obstacles and arrive safely to the robot. Okay. Vector 2. One comma O comma, and I'll just copy this. One. That will be step down. 2 1 comma 2 1. Next step. Next move, next cell. This is like a baking the pot. I would call it cheating. This is not AI. There's no AI here. AI would mean running an algorithm that would test and record which cells to move on to. 4 1 5 1 5 2 4 1 5 1 5 2 5 2. Well, do I need the last one? Add another one. That's this. Copy and paste what? Should I move it? Do I move? Let me just copy this in clipboard. Okay, there she goes. Okay, it should meet the robot. Reset. All paste. Vector 5.3. Is that the fact? 5.3. Run. Control A, copy, run. Oh yeah. Oh, you nasty. Okay, there she goes. Selecting units in this tactical game, the player and computer can select multiple units at once. You need to call the select units function and pass it an array of vector coordinates to know which units are to select. Each vector 2 is the array represents a cell with a unit. Each vector 2 in the array represents a cell with a unit. You can pass arrays in function calls as arguments. As an array is a value type the computer recognizes, you can pass the whole array as a single function argument. Selecting all units on the board by passing the correct select all units on the board by passing the correct array to the select units function. I'll do it outside and I'll say selected units, and that needs to be variable declaration equal array of vector 2, not 23. What's this? 1.0. Copy, paste, 1, 2, 3, 4. Where are these guys at? 5, 1. Let's say next one is 5, 1. 5, 1. Vector 4, 4, 2. And the last one 0, 3. Select units. Selected units. Copy, run. 03, which one, where is the 03? 04, I said 04, I'm supposed to say 03, okay. 03. Got you, I've got you, buddy. Got you selected, buddy. In reality, this would include, in real use case application, this would include area, solid, collision body shape area, with the rectangle being drawn over the area by player. Looping over arrays. We use the range function in combination with for loops. Function range, okay, print number. The range function produced an array that the for keyword could loop over. We can give for loops any array, and they will loop over them just the same. So instead of using the range function, we could manually write the numbers and get the same results. Yeah, got it. Oh, 1, 2, okay. Square brackets, remember that. The syntax: for each element inside the array, the for loop extracts it, stores it in temporary variable named number, and executes the loop's code once. Inside the loop, you can access the number variable, which changes on each iteration. The code works regardless of the array or where you store it. Often you will store arrays in variables for easy access. Variable numbers: 0, 1, 2 for number in numbers. Print number. What will this code print? Var numbers, number in numbers. Making the turtle walk in the loop. In the previous lesson, you made turtle walk along a path by writing vector coordinates in an array. It's a for loop that makes the turtle walk along the path. The loop works like this. For each coordinate in the array, it moves the turtle once to that cell. Function move path for cell in path turtle.move to cell. It's the same principle with units selection. For each coordinate in array named selected units, we check if there is a unit in that cell. If so, we select it. In that case, we use an array, a loop, and a condition together. Units equal. Okay, this is empty array. Selected units, empty array, initialization to nothing. Actually, this is also, I think, deleting, clearing the array. Select units cells. For cell in cells. Okay, so here it goes. Here it starts. For cell in cells. If cell in units, selected units appending a cell approved by this condition. Update. The code above uses several features you haven't learned yet. In a condition, the in keyword allows you to check if a value exists in an array. So in will check through the whole array to find if the match exists and return true or false. It will go through the contents of this array. The array's append function appends a new value at the end of the array. So this one will grow by this, and it will be appended at the end. Notice the use of a period after the selected units variable to call the append function is because this function exists only on arrays. That's why it was initialized as an array at this point in code, an empty array. If it wasn't assigned a type, this is type assignment for uninitialized. So this is just type assignment, but not initialized, or assignment and initialization to nothing. But let's just consider it as take it as a type assignment. Otherwise, we couldn't get the array probably call. When function exists only on a specific value type, you write a dot after value to call the function on it. We'll revisit those two features again in following lessons. The beauty of loops is that they work regardless of the size of your arrays. The code just works whether you have 1 or 10,000 units to select. It's all accomplished with only a couple lines of code. That's the power of computer programming. In the following practices, you will use arrays combined with for loops to achieve similar result. Move the robot along the path. Our AI pathfinding algorithm is giving us a path to move the robot. Now you need to make the turtle move along the path. Okay. There's already a path. Move the robot along the path. Our AI pathfinding provided a path. Your task is to use the for loop to make the robot move. To move the robot, call its move to function like so. Robot.move2. The move2 function already exists on the robot, which is why you need to access it this way. So for okay, step in for step in range. Do I say in range? No, I don't need for step in robot path. Do I say it like this? Path? Was that it? Hints. Hint 1. You need to pass the cell position to robot's move to. Okay, I got that. For step in robot path. Is that all? Is this all? So move robot dot move to. Well, let's go step move to step. Let's see what will happen here. And he goes. There he goes. There he goes. That was simple, like I don't know, peanut butter sandwich. Oh, next one. In this section, we want to draw many rectangles, something surprisingly common in games. However, writing this code by hand can get tedious. Instead, you could store the size of your shapes in arrays and use a loop to draw them all in batches. That's what you'll do in this practice. Use a for loop to draw every rectangle in the rectangle size array with the draw rectangle function. The rectangles shouldn't overlap or cross each other. To avoid that, you need to call the jump function. Okay, I call jump function and jump function by what amount? Hints. Hint 1, 2, 3. Each value is vector. You need to access it while to draw rectangles. Okay. Draw rectangle function. for each vector. In the loop you first need to call draw rectangle and then jump. Okay, otherwise at least two rectangles will overlap. Jump by how much? But how? Jump where? Offset. Okay, jump. Okay, that's the fact. So four rectangle sizes for rect in rectangle sizes or rectangle sizes. Draw rectangle. Draw rectangle. Draw a rectangle. Rect.x .y. Jump. So 275 dash 75. How about that? How about that? We happy now? Doing good so far. Let's check the solution they provide. So this could have been also rectangle size. This function could be also, in another example, made to take the vector 2 itself, full vector 2. But for, let's say, for the generic or basic rectangle constructing drawing logic, we need its height and length. So we take each of those dimensions separately. Rectangle sizes. Okay. Strings. Throughout this course, we've mostly stored numbers in variables, but what if we want to store a player's name? This is where strings help us. Strings are instrumental in games and applications. We use them to display information such as description of a spell or name of a character. Yeah, robot. What are strings? A string is a value type which holds text. To create a string, you write text wrapped in a quotation marks. For example, this is a text string. The quotation marks differentiate string from other value types and function names. You may remember we used strings before in previous lesson. Is everybody in? Following? Cool. You may remember we used strings before in previous lessons. Okay, run. Robot. Under the hood, strings are arrays of characters. In fact, we can use a for loop to loop through the characters of a string as we would with any other array. So, for character in robot, print character robot. But I guess the default behavior of print is adding a break line. Whether it's printing any character, well, after, I guess each call after sequential calls for print Which one of these are strings? This one, this one. Why we use strings? Every piece of text you see in this app is a string that Godot is displaying for us. Much like how vector 2 variables make calculations easier, string variables come with many helper functions and tricks we can use. We can use arrays to store strings too. This is useful for chaining animations. In this example, the play animation plays a specific animation. Okay. Combo, jump, damage, jump, level. What? Prefer combo for action in combo, play animation, apt. What? Oh, okay, that's plain animation, that's not the actual. Okay, so jump, damage. In the next few practices, we'll use strings in combination with different concepts from earlier lessons. Give the robot a readable name using strings stored in a variable. Okay. Change the robot name variable so that it's a string instead. You can give it any name you'd like. Okay, but I see a wrong approach here. Huh? What quote? What quotes? What are the quotes? Ah. Try again. So they already defined the variable, initiated it, and me adding a var made it like invalid. Invalid. Using an array of strings to play a combo. In this practice, we'll chain together animations. Using an array of strings, you might find such combinations in fighting games. The robot has the following animation names: jab, uppercut. Populate the combo array with animation names as strings: combo, jab, jabba, upper. Then for each animation action in string, call the play animation function to play. Okay, four. Move in combo. For moving combo, okay, gotcha. Play animation, play animation, combo. Oh no, move, like a move. The array should contain 3 values, so the robot makes these 3 attacks: 2 jabs followed by 1 uppercut. Okay, 2 jabs. Oh my, jabbity. Can we see that again? Okay. Next. Functions that return a value. There we go. Functions that return a value. Until now you learned that functions are sequences of instructions you give a name and you call anytime. You can call anytime. On top of that, functions can make calculations and return new values. Let's look at some examples to see why it's useful. Built-in functions that return a value. Many functions built into GD script make calculations and return a new value. For example, the round function takes a decimal number as an argument and gives you back the new number rounded to the nearest digit. Round 3.4. Run 3. Imagine you have a game where you track players' health as a percentage, a decimal number going from 0 to 100. Then displaying the health on the interface, you'd want to show the decimal part. In that case, you may use round function like so. Health, 3, 7, 9, 80. Oh. Set text rounded health. Set text rounded health. Rounded health. Okay. And notice how we assign the result of the function call to a variable. Okay, so rounded health is function call. Return value from a function called passing health. Above we assigned it to a variable, but you could also do the following. Just put that all in the set text. Round health in the set text round. Okay. You can assign the return value of any function, of a function call if you plan on using it more than once. You can assign the return value of a function. You can assign the return value of a function call if you plan on using it more than once. Okay. A cooler example, LERP. The LERP, a linear interpolate, of course. Who doesn't know about linear interpolation? I do it every day, more than once, several times a day. Calculates and returns a weighted average between two values. It takes three arguments, the two values to average and a value between 0 and 1 to skew the result. In game programming, it's used to animate things moving towards a target with a single line of code. Oh, come on. Position equal position. Get local mouse position. 2 times delta. What? It takes three arguments. The two values to average and the value between. Okay, so this is the value between the last one. So these are the ones to average from. And what's the interpolation being done here? Position. What's being interpolated here in position? Position equal every frame the code calculates a position somewhere between the turtle and the mouse. Every frame, the code calculates a position somewhere between the turtle and the mouse cursor. The lerp function takes care of great. And the lerp function just takes care of everything. It's not the most robust approach for smooth movement, as you will learn in the future, but it's helpful function nonetheless. Writing the function that returns a value. So actually, well, this was the example of inbuilt function that returns the value. So the current position and this position we are getting a new position kind of averaged by this factor or parameter between these two, and that will be new position that will be like updated, I guess. You can make your functions return values. To make function return a value, you use a return keyword followed by the value in question. In previous lessons we had characters walking on grids, and for those practices you are working directly with cell coordinates. Well, cell coordinates don't correspond to positions on the screen. To find the center of any cell on the screen, we need to convert the cell's coordinates to a position on the screen in pixels. No way. Or is that yes way? So cell world position 60. Okay. I understand the gist of it. To do so, we use a function. The function does two things. First, it multiplies the cell coordinates by the cell size, which gives us the position of the cell's top left corner on the screen in pixels. Then we add half of the cell size to get the center of the cell. The function returns the result, allowing us to store it in a variable. Okay, I get it. Cell size is this. Convert to world coordinates cell times cell size. What function okay, so we get some cell, and we got the hard-coded grid, single grid cell size, and for one cell in question, we pass it to this function that will return a result of this expression, which takes into calculation the past cell value to the function call times cell size. So what do we have here then? What would be the cell? Probably the same type, some vector cell. What? That would be coordinates. Okay, plus cell size. The return keyword returns the value to the code calling the function. You'll receive the result where you call the function. Okay, so world position equal convert to world coordinate vector 1 print world position. Okay, run. Some functions return values and some do not. During practices, you can learn which functions return a value using the documentation panel. It will display if the practice requires using specific functions or variables. There, functions that start with the term void do not return a value. Any other term means the function does return a value. You'll learn more about what other terms mean in a couple of lessons where we explore value types. We explore the value types. For now, let's practice returning values from functions. So, converting coordinates from the grid to the screen. We lose the function to convert grid coordinates, but we desperately need it for our game. Make the turtle move again by coding it. Wow. Cell size vector 8080. Define function that converts a position on a grid to the screen. The function takes a vector to cell coordinate as an argument. It should return the corresponding vector to screen coordinates at the center of the cell. Well, return, of course, I remember all of it. Return the cell. So I get the coordinates, and those coordinates are what? Top corner. And why multiplying? Why would I multiply that? Or add. So cell size hints every cell is a square of size. Cell size, you can multiply the cell by this value to calculate the top left of a cell. Okay, to calculate the top left of a cell in a screen coordinate, so that's why I multiplied. So again, why multiply? Why would I multiply it? If this cell is in question, it has this coordinate and size of this. Top left, and I multiply that. Why? You can multiply the cell by this value to calculate top left of a cell in a screen coordinates. Hint 2, to get the center of a cell you need to add half the cell size to the product. Well, okay, cell size minus cell size divided by half of it. Give me half. How come? Oh, plus add. Was this the thing here? Okay. Stay. Can we see your solution? I understand the whole approach, but I'm just having, it's challenging. I want to have it settled in my mind, the actual why multiply those coordinates, but we are multiplying vectors. Is there a difference? Do I just do some linear algebra on each sub-coordinate, some sub-variable, or I understand adding. It was described properly in the first previous lesson section, introduction. But anyway, keep it going. How far I am into this? What's my progress here into this course? Appending and popping values, is this course procedural? Infinite? Maybe it just creates new lessons as I finish the previous one, the current. Appending and popping values from arrays. In previous lessons, you learned how to create arrays, to store lists of values, and how to loop over them. It's nice, but you won't go far with only that. The real strength of arrays is that you can add and remove values from them at any time. It allows you to queue or stack data. For now, let's take another example. Tracking orders in a restaurant managed game. Oh, come on. You're making a restaurant managed game where customers place orders and you need to handle them as they come. In this game, customers order meals that end up in a queue. You need to prepare them in the kitchen. As an example, we simulate orders arriving and getting completed over time. Pending orders completed orders. Tomato soup, burger, cheese sandwich. How do you keep track of pending and completed orders? With an array, when a customer purchases a meal, you want to append it to the array. Then, as you complete a meal in the kitchen and serve it, you want to remove it from the array. You can do that with the append and the pop front functions of the array, respectively. Respectable. 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 Try to read the code below before moving on. Don't worry if not everything makes sense, as we'll break it all down. Break it down. Waiting orders, empty array, completed orders, empty array. Type assignment. Variable initialization. Empty. Function add order, meal name, waiting orders, append. So waiting orders has a function append meal name, complete current order, variable first order equal waiting orders, pop front. Complete current order, first order. First order equal waiting orders pop front. Completed orders append first order. First order. So what pop front returns the first element in array. Notice how we call some functions by writing a dot. Yeah, like a given value type can have subvariables, it can also have its own functions. Functions like append and popfront only exist on arrays. That's why to call them we need to access it from the array using the dot. Okay, array dot append. Let's break down the code. We queue orders in the waiting orders array by appending them to the array. Waiting orders, waiting orders. Function add order, meal name, waiting orders append. We can use a string to represent a meal when calling the add order function. Add order cheese sandwich. When completing an order, we remove it from the waiting orders array by calling its pop front. This function gives us the order back, which allows us to assign it to a temporary variable. Pop front. Tell me more about that pop front. I want to know more. When completing the order, we remove it from waiting orders array by calling its pop front. This function gives, it gives the element, it returns the element that we removed from array. Say it like that. That's the proper description. It's not just give me that element on that place in the array, but it says, okay, take that, remove this, element. So waiting appear, cheese, waiting pop front. So I guess first order is the first in line. That's because it doesn't take an argument. It's whichever one is, let's say, last or first. Hashtag mean we call arrays append what? This what does hash have? We write hash 3 dots to represent ellipses in the code. It means we are completing the function's code. What? We use that to break down code examples and make them easier to learn from. What? Okay. So what they're doing? Completing the right hash 3 dots to represent ellipses in the code. It means we are completing the function's code. We use that to break. We are completing the function's code. Use that to break down code examples and make them easier to learn. Okay, hashtag itself marks the start of code comment. It's a line. Okay. Using arrays as stacks. Another common use of arrays is stacks of data. Take a factory management game where you need to retrieve materials from stacks of crates. They arrive at the factory piled up vertically, and you need to take them from top to bottom. Variable crates. Healing, heart, shield, sword. Function use top crate, variable crate equal crates pop back. Use crate. What? Oh, that's a second instruction. Use crate that's popped back. To take a crate from the back of the array, this time use the pop back. Okay. This function removes pops the last value from the array and returns it to you. Here we pop the last value of the array and printed what's left of the array to demonstrate how the array gets smaller. Run. How the array gets smaller. Social gems. Soul shield. Go back. One call, okay. That was just one function call. Just one. I like it. The value in question could be the crates content, which you can then use to give resource to the player. In following practice, you will use the append, pop front and pop back array functions in the following practices. Cool. Let's do it. Let's pop some array elements. Okay, what's going on here? The waiting orders array will be used to move orders from waiting list to the completed orders list using the arrays append and pop functions. Remember that the array's pop front function returns the popped value, which allows you to store it in a variable and then pass it to another function. Completed orders contains all elements used, append used, pop front. Yeah. Complete current order. Complete current order. So current order function complete the current. Okay. So complete the current order, which is actually front in the waiting orders, and I want to have that in my completed orders. Maybe it will seem super simple, like let's see, completed orders, completed orders, dot append does this do I pass or say equal? But hint one, how is this? What was this call? Blah. You first need to pop the first value from the pending orders array. To pop the value from the front, you call array pop front. Okay, but complete orders append. So do I just say equal? Waiting orders dot pop front, right? Pop front. I think we got it. Completed orders append to an expression. I can't assign to an expression in clearing meals. Completed orders, completed orders. What? Hey, I don't remember these two things. What's going on here? Where did the dots come to play here? When did this happen? When did this happen? Oh, I need to go back, check this out. Yep, leave unfinished. When did this start happening? What's going on there? Why is that like that? How can I go one more back? Okay, so there aren't columns in the so far. I've just so it's clear initialization equal assignment type assignment, and let's go. What's going on here? Where did this come from? So completed orders that append wait, let's go back. What's the how does this work? Wait, append pop creates pop back, top create pop back. So I get, okay, I assign that. Okay, I need to pass the, it takes an argument. Okay, I understand. I was curious about that. Meal name, waiting orders, add order meal. Add order meal name, waiting orders, append meal name, okay. I can try just to maybe write down the write down the short maybe one-liner. Cool. Well, again, what are these two dots here doing? Columns completed orders completed orders dot append and just pass the waiting orders of front. This might work exactly like this. Well, let's say PHP can take this format. It's possible to pass a value by function, a return value. So you call a function in the same place where you pass a value in another function call. Modern programming languages allow that. Maybe not the best, but maybe code efficient, like writing efficient. Let's see, does it work? Yeah, it does. So I didn't use in between intermediate carrier variable. Clearing up the crates. Crates are piling up on the platform. Move them out of the way by popping them from the crates array. You need to remove them from top to bottom using the array So last, so well, okay, okay. Last is the top one, so everything is sitting on top of killing heart, shield, gems, and at the end sword on top. I need to remove them from top to bottom using the erase pop back function. My code should remove all the crates in the array using the while using a while loop. While loop? Huh? Careful. If you run a while loop carelessly, you can lock the software. You can check if the crates are still contains while crates by writing while crates. Huh? Okay, while crates. While crates. While crates. Crates. Hey there on Day5, how you doing? How you doing? How's your day? So crates, crates, dot, up, back, while, and anything else. Anything else? Pew, 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 using while loop. Is this the best way? I would think twice before using just like that a while loop. I would first use a broom and sweep everything before committing to a while loop. You learn to loop over all the values in the array using for keyword. Okay, for value in array. But if you need to access the third item into player's inventory, then the 10th item, there's a dedicated notion to access one element in array by index. To do so, you use square bracket with a number inside the brackets. Array name. Array name. Inside brackets. Anyway, super thanks for follow. Over there, that's my first guy, OG guy on Day5. You're the man. Here's the man. There's the man, or lady, or lady man, lady. I don't know. I'm dropping it. Who knows? Okay, this is a new chapter, and 3.5 hours in the stream, and 1 hour earlier. There is this is a cue to take a short break. Run the Chiptune Sam TV. Oh, I'm here. I'm here. We'll continue with this. I'm still really not clear how far I'm into the whole course, GDScript course, but I really like the pace and the approach they've taken. Feels good. Feels I feel accomplished. Even if, well, I already talked about this, like learning new things, being creative, building something. I don't understand. People rather go to work and take someone else's instructions what to do, and like, oh, I don't want to think, I go to work and I do what my boss tells me. So why don't you be your own boss and tell yourself what you want to do? Well, I don't have the start budget, the investment. That would be the capital. Well, investing money means you take something worthless, trying to extract value, get some tangible value, even if it is a meta, if it is information. Money not invested is just rotting paper. That's why it's mostly digital. It rots, less rotting happening. Okay, dial this down, switch it back here, put the show soundtrack on, and let's do the accessing by index. Array element accessing by index. To do so, we use square brackets. Okay, array name. Okay, array name index. Index 0 is the first element in the array. No way. Run. Okay, there we go. Can I change it? No. Index 1 is the second element. You would access the fourth element in the inventory array like so. Index 3. How would you access the third element in the inventory array? 2. Accessing the last values with negative indices. What if you want to access the last or second before last item in the inventory? In that case, you can use negative indices. If you write -1 in brackets, you will get the last item in the array. No way, that's like touching my own, licking my eyeball. You will get the second to last item if you write -2. Fancy. that can get weird. That's very convenient when you need to quickly access element from the end of the list for some reason. How would you access the third to last item in the inventory array? Well, I guess -3. When using negative indices, -1 means the last element. There is no -0, so the first element is 0. The one before the first element is the last one, so -1, -2 means that ordering seems no proper. Yeah, but that means well, it's still, well, anyway. What if I overshoot? What if I go too low, too negative? What if I'm too negative on the array? You can't access non-existing indices. There's a catch with this syntax. If you try to access an index that doesn't exist, you'll get an error. You have to be careful always to access existing elements in the array. There are a couple of ways you can check for valid indices. One of them is check the array size. Yeah, give me the size so I know how much leeway I get. How much? Checking the size of the array. Arrays come with a member function named size. Yeah! Member size. You can call it on the array anytime to know its current size. Run. Oh, 1, 2, 3, 4, 1, 2, 3, 4. Run inventory size, return print, cool. The maximum index you can access in an array is array size -1. It's the last item in the array. -1. Boing. 5. 1, 2, 6, -1, 5. Yep. Okay. I've got that. That's sunk in good because I know it from my previous job a few years back when I was coding something very intense, also involving meals order session ordering queues and array of orders preparation, order queue, and also billing the issuing the invoices for a placed order, closed order, paid order, using the right items. Find the right items to use in the player's inventory. In our game, the player has an inventory that works as an array under the hood. They want to equip a sword and a shield to buff their character. Like before, we need you to find them in the array. Find them in the array. You need to access elements in the inventory array by index to do so. Call the use item function with the item as an argument to use an item. For example, you can use the first item by calling the use item inventory 0. We want sword and shield, right? One, two, three. Okay. I'll do it. Inventory. What's up with this inventory? Use item, inventory 0. Pick items. Do I need to fill this array? Hint. Use the function use item where item is an element of the inventory array. What's hint 2? Wait. Check. Okay, this is super straightforward because it's just like it shows. And I'll actually do this. Cheating. I said cheating. Copy. Paste. Don't need the dot. 3. Paste. 4. Run. Oh, no member here. That dot slipped. Wait, stay. Why? 3. Okay, so I meant 2 and 3. Yeah, that's what so they are, I'm calling them, passing this index to get the exactly the one. And the music starts. What's this? We have train tracks broken down into little chunks in our game. We use them to make modular tracks and draw circuits of all shapes and sizes. However, several chunks are misaligned. You need to find them in the tracks array and pass them to the align function. What? To do so, you need to access the array by index. First, this time though, you need to access them with negative indices. Okay, fix tracks. Okay, tracks, fix. Align. Align. Tracks. -2. Copy. Yep. And -1. -1 and -3. That's it. Ruining your code. Why? Wait. Reset. Wait. Something smelly here. 1, 2, 3. Hey, it's 3 and 4. Oh. Okay. I took this too lightly. There are 3 off misplaced items. It's the first one, and then 3rd and 4th from the end. 3 and 4. There are 3 misaligned bits. But I'm not finding them, I'm just looking at what's there. I'm not using any programming to find misaligned tracks, but hey, there we go. Ruining your test. Ruining your code. Okay, lesson complete. Creating dictionaries. In the last lesson we used an array to represent a player's inventory with just an array of items, item names, though we can't easily keep track of the amount of each item. So key value pairs, there we go, and it's curly braces. Oh, curly brackets. Here we go. With just an array, though we can easily instead we can bundle the item names and amounts into a single dictionary. A dictionary is a data structure that allows you to map pairs of values in the pair. We call the first value a key as we use it to access the second. In other words, a dictionary has a list of keys and each key points to a value. To define a dictionary, we use curly brackets. A column separates each key and its value, or separates the pairs. A comma separates each key and the value pair. Dictionaries can hold any values. Dictionaries can map about any value to any other value. For example, we can use the name of an item as a key and the amount as the corresponding value. This makes dictionaries excellent for keeping excellent for making things even more abstract and complicated. Keep track of a player's inventory. Okay, variable inventory equal open curly braces, key, healing heart, name of the item, value, pair value 3. Gems. Okay, so it's not strict type, loose type. It's almost just like the JSON format we'd expect. Here we match the name as a string to the amount, a number, but a key could be a string, a number, or even a vector. Although we can have all these different keys, keep in mind that every key has to be unique. That means we couldn't have a dictionary like the following: shield, heart, healing heart, sword, healing heart, a... Oh, no. Error, duplicate key found in dictionary, literal. In the above example, which key would cause an error? How dictionaries work under the hood. Dictionaries are also called mapping or associative arrays. There you go. Under the hood, they use arrays and several functions to efficiently store and retrieve values across arrays. Precisely, dictionary uses a hashing algorithm. Hashing algorithm converts one value into another. In this case, hashing consists of converting a given key into a unique whole number. The dictionary then uses that number as an array index. That's how a dictionary works. When you give it a key, it converts it into a unique index and uses that index to retrieve a corresponding value in the computer's memory. That's also why you can't have the same key twice. It would map to the same array index, causing you to write an existing value. Accessing values. We access the value of keys by writing the dictionary name. with the key in between squares. So dictionary key. What? Oh, accessing values. Okay. Dictionary key. Okay, name of the dictionary and give me the passing the key representing the index. Okay, I got it. Gotcha. How would you access how many gems the player has? Like this. We can also change values directly, which is useful in our case for adding or removing items from player's inventory. Inventory healing heart plus equal 1. 4. Gotcha. Reset, run, cool. In the following practice, we'll use the dictionary to create a player inventory and create a function to change the value of items. Okay, create an inventory using a dictionary. Collecting items is fun, but we need a good way to store them. Write a dictionary to display the player's items. Let's give player some items. We use dictionary for the player's inventory. Yep, we defined the inventory variable for you, but it contains no items yet. 3 healing hearts. Healing hearts. 3, right? Was it 3? Go. Okay, like that. Gems, 9 gems. 9. And single sword. Okay, cool. One sword. The key should be text strings and values whole numbers. Oh, healing heart, not hearts. Gems are plural, these are singular. Okay, has inventory has spread keys. Come on. Stay. Can I see that again? Gems. Okay, I'll just copy this. Ctrl A, Ctrl C, reset, Ctrl A, paste. Paste. Run, let me see the inventory animated. Oh, no special. Nothing fancy over there. Increasing item counts. I want to change the item counts in the player's inventory whenever the player picks up or uses an item. We've started the add item function for you. Oh, thank you. The inventory dictionary should use the item name parameter as the key to access its value, and we should increase the value by amount. Okay. To test this practice, we'll use your add item function to increase the item count of healing heart, gems and sword. Add item. To test this practice, we'll use your add item function to increase. Okay. By how much? But how? Increase by what? Amount. By the amount. Is that the thing? Int item name amount. Item name. We want to change the item counts in the player's inventory. Started. Add item. And okay, so inventory should take, how is that, what's this, what is the syntax? Okay, this is the square brackets. Item name. So item name is the key, like index, and I get it holds the amount. And how would I operate on the amount? Okay, so element on the key or index increase by amount. Is that true? Inventory, come on. And that would conclude this part 2, day 5. Let's be it. So do I need the go further, looping over direct dictionaries for item name in inventory, keys print. Inventory, okay, keys, member, it has a member function, cool. I remember that. I do remember that. I bid you farewell, but also just a formal recapitulation that I usually do. I hit stream marker, so I will not scroll through the through this. Can I have the top of the page? Where's my, okay, close the Windows magnifier. Looping over dictionaries. Do we have here a index content on the side? No. What's this version? Okay, so I thought maybe to scroll through this, at least highlight the titles of the lessons. And if I show a video clips from this part 2, day 5, it doesn't provide anything special anyway, so I can just switch to the host scene and say a few final words. Also for this session recapitulation, thumbs up to this course, GD Quest application later to learn the Godot scripting. well, this second segment is related, for at least this part that I remember, arrays, using the arrays, and also, actually, I think first part was hour and a half. Conditional if statement, and introducing also if else. Then looping function, actually in a branching sense, for loop and while loop to conditionally repeat a given block of code. And after that we went into those boy from Neverland. Say it. I'm listening. What you need, lost boy? Lost boy. And at the end, after that, for loop, if then statement, arrays, going through, working with arrays, accessing the array elements, and now dictionaries. That's what you'll find in the recording of this stream. Now back at you, lost boy. Come on, don't be shy. Yeah, I got the advice. Either say it or because I'm on my way out, I'm closing the stream. So, we're all waiting here. Yeah, that's great. Advice on getting money. Well, I don't know. Get a job. Build something. Capitalize on some skill, knowledge. Learn, maybe. We are on internet. Maybe learn to code. I don't know. Getting money. For last 100 years, 1,000 years, people work for money. Since the invention of money, if it's on getting money and getting laid, oh, getting laid, well, get laid. You, I don't know, it depends on the method. What method do you prefer? I don't know, punch in the head and you get laid down, or maybe a strong, try to sweet talk a stronger lady, she can put you up and get you laid down. You want to lay down on the floor, on a board, on a table, kitchen counter, on a balcony rail, get railed. Thanks for that follow. Hey, why get upset? You asked for the advice. That's the best I can give you. You know, you heard it here first. Free advice. This is the advice section, advice segment. Advices, free advices. I didn't say I give great advices. They're free, but they're not great. Well, those are the ancient questions, but they're simple. Everybody gets the lady and the money. That's what everybody can get. Even the most incompetent people get one and the other thing. It's actually simple. Just need to go and ask. But even if I had one and the other thing, I can't give them over the internet. You need to go offline and go outside. That's where that is. Go first, go the other way. You can't sit online and ask for it. I can't deliver. I'm not Amazon. You know, check AliExpress or Amazon. They sell some kind of that thing. Do you ask me, do you want to look at those things? I can show you images of money and lady things. But you want to own them, like I won't get that I own, you own. Anyway, I'm on my way out. Thanks, big deal for that follow. During the work days I'll be doing more of this. Stay safe and use the contraception. Going to the outro.